Grade 11s, we're on our new topic, sequences and series. Today we're going to look at recursive sequences. So first of all, a sequence, which you have seen in 6th and 7th grades, is an ordered set of numbers that follow a well-defined pattern. Okay, ordered set of numbers that follow a well-defined pattern. Those of you that love patterning, this is going to be fun. Each number is called a term, and when it follows a specific pattern, they have a position in the list. So we're going to have a look here. General form would be term 1, all the subscript, term 2, term 3, and so on, where our Tn is the general term. And we'll define that a little bit more. For instance, if you had terms 5, 7, 9, and so on, the third term is 9. Okay. So the general term is used to generate one, several, or all of the terms of any sequence. For example, okay, so it generates one, some, or all of the terms. For example, if Tn equals 4 plus 6 times n, our first term, there's the notation for that, would be 4 plus 6 times the number 1. The second term would be 4 plus 6 times the number 2, which is 16. Third term would be 4 plus 6 times 3, 22. So answering for general terms, it says calculate the first 4 terms for each of the following sequences. So term n, general term, is 2 times n squared. So I want term 1, term 2, term 3, and term 4. Term 1 is 2 times 1 squared, which is 2. Term 2 would be 2 times 2 squared, which would be 8. Term 3 is 2 times 3 squared, which is 18. And term 4 is 2 times 4 squared, which is 32. We could write it as a sequence: 2, 8, 18, 32, ... Second one, B, says the general term is a half n cubed minus 3. Term 1 is a half 1 cubed minus 3. A half subtract 3 is negative 2.5. Second term is a half times 2 cubed minus 3. 2 cubed is 8. 8 times a half is 4. 4 take away 3 is 1. Third term, a half times 3 cubed. Ugh, that one's going to be ugly. 27 times a half is 13.5. Take away 3 is 10.5. Fourth term, a half times 4 cubed minus 3. 4 cubed is 64. Divided by 2 is 32. Take away 3 is 29. If you find a boo-boo, you get a bonus mark. All right. The next one is not written in general term form. It looks like a function. But let's find term 1, term 2, term 3, term 4, which we would normally write as ordered pairs when it's in function notation. But for term 1, I have 3 times 1 plus 1, which is 4. Term 2, 3 times 2 plus 1, which is 7. 3 times 3 plus 1, 10. And 3 times 4 plus 1 is 13. We would write that as a sequence 4, 7, 10, 13. And we can see that we're increasing by 3 for each subsequent term, or our slope is 3 in our old functions. Let's write the middle one here. Minus 2.5, 1, 10.5, 29. That's a harder pattern to see. We're starting with the Fibonacci numbers, where each term is generated by the previous term or terms. So in any recursive sequence, you use previous terms to find the next one. So for Fibonacci, we would write it as term 1 equals 1, term 2 equals 1, and now that we've gotten ourselves started, we can write the general term from there on would be looking backwards and adding. So for any term, we would look to the one previous. Note down here that t subscript n minus 1 means look one term back. Add it to the term 2 back. So to generate term 3, for instance, we look and we add terms 1 and terms 2. Term 4 we got from adding term 2 and term 3, and so on. Oops, term 3 and term 2. Didn't want to get it in the wrong order. For the next one, 2, 6, 18, 54. Sometimes it's hard to see these patterns, but we need to get ourselves started. For term 1, we start with 2. From there on, we would multiply the previous term by 3. This third one might be harder for you to see. I wouldn't mind you pausing for a second and seeing if you can figure out the pattern before we start to write it down. For this one, I would need to get it started. My first term is 1 and my second term is 2. How would we generate subsequent terms? Let's just see. Term 3, which is negative 1, appears to me that it would be the first term, take away the second term. Would that work for the next one? T4 is 3. Would it be true that that would be term 2 take away term 3? So it's following the same pattern as the one above. Term 2 is 2. Term 3 is negative 1. Is 2 take away negative 1 equal to 3? Yes, that pattern holds if you look further on down the line as well. So term 1 is 1, term 2 is 2. General term is look 2 back and subtract the one that's 1 back. It's probably more of a challenge to find patterns and write them as a formula. We also need to be able to take a formula and generate terms as well. Oh, we have one more. 2, 12, 22, and 32. The first term is 2. I don't really need to look any further because I can see from there on we're adding 10 each time to the previous term. So from there on, Tn is look at the term before and add 10. N is always greater than 1. A recursion formula is a recipe for generating the terms, starting with the first term. Sometimes you need the first 2 terms. A recursion formula has 2 parts. It is a recipe for generating terms. you need to start the sequence. Term 1 you would give, perhaps term 2 as well, however much you need to start the sequence. And the second part is to write the terms in a general way. We should always consider as well that we would have restrictions. Sequences have a starting point, so you often have n greater than 1. Okay, the next example at the bottom says write the first 5 terms of the sequence defined by the recursion formula. This is an easier process. Term 1 is minus 7. The second term is Tn equals, look at the term before and add 4. So maybe I won't write it as a list quite yet. Term 1 is minus 7. Term 2 is minus 7, add 4, which is negative 3. My third term is, look at the term before, which is term 2, and add 4. I'll get 1. Fourth term is look at the term before, which has a value of 1, and add 4. Term 5, this will be our last one, is look at the term before and add 4. That's 9. So to write it as a list, which we often do, would be negative 3, 1, 5, oh, starts with negative 7. Negative 7, negative 3, 1, 5, 9, dot, dot, dot. Second one. Term 1 equals 2. Term 2 would be, what's our recipe? Look to the one before and multiply it by 3. So it's 6, term 3. It says 3 times the term before. Answer 18. The fourth term, 3 times the term before. And the last one, 3 times the term before. 3 times 54, 150, 162. To write it as a list, as we often do, it would be 6. I did it again. 2, 6, 18, 54, 162, and so on. I have some for you to try in your textbook, page 443 and 447.